Welcome to March 25th LeetCode Challenge. Two-city scheduling. A company is planning to interview 2N people. Given the array cost, where cost at index I is equal to the the set of the a cost at index I, B cost at index I, where you have the cost of flying the ith person to the city, which is at city A, which is the A cost at index I, and the cost to fly the person at index I to the city B, costing B cost at index I sub I. Return the minimum cost to fly every person to a city such that exactly n people arrive in each city. Okay. So basically, we want to, another way of saying this is that we have to interview 2N people, and that means that we have to bring a person at each index to a person to a city, and each index will hold the cost of it, where the first cost is to city A, and the second cost is to fly to city B. And yeah, that's pretty much it. Alright. So we have example 1 where we have the array cost here, and we want to find the minimum cost to fly every person to a city such that n people arrive in each city. Meaning that if you give an example number 1 here, if the first person here has the cost A being the A cost being 10, the B cost being 20, that means that we have to fly basically person A from city A with a cost of 10. And then the second person goes from city A, which is 30, and then we want to fly to the second, so the person B, no, person index 0, 1, 2, this person here, they're going to fly to the city B because it's cheaper. And then the fourth person flies to city at B as well because it's cheaper with 20. So the minimum cost is 10 plus 30 plus 50 plus 20, which is going to be 110 to half of the people interviewing each city. So that means that we have city A is occupied by 2 person, city B is occupied by 2 person as well. So we have 2N people. And if that didn't make sense, let's kind of go over this example. Well, we don't have the answers, but say we would choose the lowest cost, and also we want to find the lowest cost such that 2N of it would be, that means that the first person or second person, they have to be equal amounts of places to interview. And that's essentially it. We have the length of cost is equal to 2 to the n. Cost of the length of the cost is between 2 to the 100. The length of the cost is even, which is good. And B cost and A costs are between 1 to 1,000. So overall, this is a pretty lengthy slash not too simple of a question, but let's try to aim for a reasonable solution. So let's say if let's think of some intuitions, some ideas to solve this. Say we take the smallest relative difference between two options, right? Say we have two options. Let's go with this one, it's a lot better. So what does relative difference mean? It means that, let's say that we have, let's copy these two, yeah, these two. So we'll take the relative difference. So say that we could represent the array as A to B, right? And we want to find basically how big is the difference between the cost between A and B. So the difference between the relative cost difference between A and B from the first person in the move is 20 minus 10, which is equal to 10. The relative cost difference between this person right here, between A and B, is 200 minus 30, which is equal to 170. So we see that the relative cost difference for a person in the second index here, or first index, I should say, this person right here, the relative cost difference is way larger than the first one. So we want to prioritize this value right here, where we're going to take the 30 mark. So it's better to choose 30, which is a lower for this person right here, to go to city A, because the relative cost difference between 30 to 200 is dramatically different compared to the first difference, right? If that makes sense to you guys. So so to do this, we want to find the relative cost difference, and we should also sort the array first. And then we sort the array with the most negative numbers will go to A, and well, the largest number between those two goes to A, and the most positive and the most, I should say, the most smaller number will go to B. Right? So comparing this, having a larger value, we're going to choose location A, and this is smaller compared to this one, so we're going to choose location B if we have to. Right? If these two are the two things, because remember, we have to make sure that 2n people. So it means if A goes to, if this person goes to A, this person here has to go to B. If we only have 2. So that's pretty much it for that. So let's go sort this out. So first thing we want to do is sort the costs. Not sort. How we're gonna sort it. So this is a bit tricky. We want to basically sort the array right here, and we're gonna use a special. We're gonna use a lambda value here. So the key is gonna be key lambda. And x is going to be, so what is x going to be? So we want to take the relative cost differences, so we're sorting it by relative cost difference. So we can actually put that directly into the sort parameter as well. In order to do that, we just do 0 minus 1. So what I did before was basically the cost difference. So we're taking the first value, which is A minus B, so essentially if B is larger, then it's going to be more negative, so we're dealing with the negative sort. So that's pretty much, we're sorting it by relative cost difference. Next thing we want to do is find the length of the cost. We also wanted to make sure that it's we're interviewing 2n people, so we can divide that by 2, which is going to be basically going, one person has to go to one city, the other person has to go to the other city, right? And then when we have that, we have our output, which is going to be our minimum cost to fly every person to a city, such that exactly n people arrive in each city. Alright, we have that. Let's move some space here. So this is pretty much the hard part right here. And also, yeah, that's pretty much it. Next thing we do is do a simple for loop for I in the range of n, because it's halfway, right? It's a integer division. We are going to increment our output by the cost at index I 0. Meaning that we are going to increment the cost of the output with the cost at the index I for each of the elements in cost. Alright, that means that if we are able to sort it, we take the first element, and then we put it into our, we just basically add up all the costs into our output, right? Cumulatively. So the next thing you want to do is also, so we want to basically take the most negative number and go to A, and we will also take the most negative, a positive number, we'll go to B. So we know that this location is going to go to A, and then we also want a location that goes to B. I in range between n to the length of the costs. We are going to output our incremented by the costs at xi1. Alright, return output. Alright, if you guys didn't get that, let me go over that again. So basically we sorted the array, and the first half of it, since the relative cost difference is very small, we're going to choose them all to go to A, essentially. And then halfway through our n value, so meaning we go beyond half of the rest, we know that each element in the front goes, each of the first half of the array that's sorted, it's going to be indexed, it's going to be location A that's going to be chosen because the relative cost difference is low. And then once we get to the halfway mark, we know that this everybody afterwards has to go to index B because the relative cost difference is very high. So we're taking the later path of it. And essentially that's what we're doing, if that makes sense. Anyways, let's submit it. So time and complexity for this would be big O of n log n because we're using a sorting algorithm. Memory complexity is big O of n because we're storing everything inside a integer variable. Alright, there you go guys. Have a great day.